All right, welcome back, everybody. So we are back. CSE 224, day 2. So how's everybody doing today? Good.
Very well.
Awesome.
Probably not as safe, but fine.
Yeah, I can relate to that one. Yeah, sleep is a nice thing when it happens. Lately, it just feels like there's so much to do, which is kind of strange because, can't go anywhere. Can't, like, really hang out with a lot of random people. Should be plenty of time. But I think the more locked down things are, the more things I'm starting and the more plates I'm getting in the air spinning around, and it just means there's like more and more time that I can spend on this stuff. So I've been crazy busy for the past few months, and it's good. I mean, nothing worse than being bored, but yeah, it's just time seems to be slipping away. But we got plenty of time in here. We're on day 2. Um, so let's talk about more Linux. So let me get a show of hands first of all. How many people currently have access to a machine that boots up into Linux? So not OS X, but a full-blown Linux distro running on a laptop or a PC. All right, so a few people, not a majority. Let me ask, how many people are running OS X, which is basically its own version of Linux? Cool. All right, now at least one person answered my next question. Is anybody running VirtualBox or some kind of virtual environment and running Linux on top of that? Cool. Awesome number of people there. All right, so I'm gonna make a suggestion that I mentioned yesterday. Um, Try to get yourself in a Linux environment for this course. Okay, it'll work really well on this course, but also for the other courses and also for a university setting once you transfer. Um, the closer you are to actually being in a Linux environment, the better your experience is going to be. That's a blanket statement, but I happen to think there's a lot of truth in it at least. So if we go to the YouTube channel that you can link through in Canvas. The second video on there is Intro to Using VirtualBox and Xubuntu. This is a good option. Sometimes dual booting a laptop is a risky thing to do, or feels like a risky thing to do. Sometimes it's not always an option. We don't have a lot of disk space. Some Windows PCs are very resistant to changing what they boot into. You have to deal with secure boot and all kinds of stuff like that. But VirtualBox is a really nice solution. And there's a full start to finish discussion of how to run VirtualBox in this video. But let me show you the effect of it. So I already have VirtualBox installed. So let me just go ahead and run it for myself. But your version of it will look very similar. So when you run it, right, you're just running a program. You're not changing anything about your operating system. You're not dual booting. You're just running a program. But that program basically emulates an x86 machine. Okay, it emulates the CPU, memory, hard drive, peripherals, all this stuff. And on that emulated machine, that virtual machine, you can install other operating systems. So you can install another version of Windows, or you can install Linux. And so I have Xubuntu, a Linux distro, that I've already installed, and the video tells you how I did that. And to boot up my virtual machine, I basically just hit this start button. And it will pop up a window. And then it basically starts the boot process. So you see a few of the boot messages and then the splash screen that you get from booting Ubuntu. And then you get a Linux machine. And it boots quickly, right? It's all done. It's actually booted up. And I can do, Control-Alt-T to open the terminal window, or I can hit my little button over there and come down and look for programs and so on. But mostly we want to work on the command line. And here we go. I'm inside a virtual machine. And, I can say, who am I? It tells me my name is Nick. I can say what directory am I in. I am in /home/Nick. There's a list of files in my directory. There's one program in there, called hi.c. And I can edit it with VI. And I can change it. And I can compile it. And I can run it. Right? And that's it. I'm on the air now with a complete Linux environment. And I'm the owner of this machine, so I can make myself a super user, and I can do administrative tasks, which means if you want to learn how to administer a Unix system, right, or if you want to get ready for administering your own, you can do that here. And if you accidentally do something like delete all of your files, right, it's a virtual machine. If you've got work on here that's important to you, hopefully you're backing it up somewhere else. But, worst case, I can just get rid of this machine and reboot a new one and be back to square one. So this is a really nice environment to work in. It's generally very fast, pretty efficient virtualization, and it's full blown. It piggybacks on top of your hardware, so I can ping Google and it's going out through my laptop's network connection. But to me, I just have hardware sitting inside this virtual machine with its own IP address, and I can use that to connect to the web, and I can get web pages and so on. And I can run a virtual browser inside this virtual machine and do all kinds of things like that. And then if I want to shut it down, I can use the usual Ubuntu shutdown. So I'll just come over here and say shutdown. And that's it. It shuts down, and now I'm back, to VirtualBox. And all of that happened inside this program, right? At any time, I could have, gone back to my operating system and done any of the things I normally do. And that works great. So if you don't have a machine that boots into Linux, I recommend downloading VirtualBox, install it, put Ubuntu on top of it. Check the video for details. I like using a distro called Xubuntu, but I'm not really picky what distro you use. Xubuntu is nice because it's pretty efficient. It doesn't do a lot of fancy graphics and stuff. It basically brings up Linux and it stays out of the way, so you can do command line stuff. But if you like a Unity interface, or if you want to run Mint or Kali or something else, Linux is more or less Linux. And we're not going to get into deep enough details that one version is going to be different from another. So play around with that, and let me know if you run into issues. But that will make your experience in all of this stuff a little, a lot more pleasant, I think. All right, let's talk about logging in and out of Linux. So at this point, most people have managed to log into the Linux server. If you haven't, and you're sending me emails about it, right, keep those going. I'll get to those emails after class. We'll figure it out. The most common issue people are running into is using the wrong username. Okay, your username is your first initial followed by your last name. And that's it. It's not first initial period last name. It's not first initial last name and a number. It's just first initial last name. Forget about your CTC link login. Forget about your CTEC login. Okay, first initial last name. Your password is 9 digits, which is your CTC link ID, followed by an underscore. So 10-digit password. And the machine is linux.engrcs.com. That's all in the how-to file on Canvas. The second most common problem people are running into is dealing with the passwords. Okay, when you log in, it will ask you to change your password by typing in your old password and then typing in a new password twice. And then it logs you out. When it logs you out, it gives you a message. If that message says successfully changed password, you're good to go. If it doesn't say that, it did not change your password, log back in with the old password. And then put that old password in again, and then put in a new password twice. Okay? So those are the two main things people have been running into. If you added the course after last Wednesday, and you're not getting logged in, and you haven't sent me an email, because you probably don't have an account on the system. In which case no password is going to get you in. So send me an email, I'll set up an account, write you back, tell you that it's been set up, and then you can follow those steps in the how-to and log in, change your password, and be good to go. If you have not tried doing this yet, do it right now. Okay, and get me an email before class ends. I'll deal with emails after class ends, and that's probably it until tomorrow. And you have homework due 8 o'clock tomorrow morning. So if you're having trouble logging in, I probably should hear about it before the end of class today. Okay, otherwise there's a chance it's not going to get resolved in time to do your homework. Your homework, you have to log in, do a couple of things, log back out. Alright, so how do we log in? Two options, putty and SSH. I'm going to say SSH is the better option. It's easier to customize, it's faster, you can set up shortcuts for it, and so on and so forth. We looked a little bit at putty yesterday, and there's also a video out here called Ideas for Customizing Putty. And if you're going to use putty, I suggest taking a look at that. It tells you how to do things like set your default font, set your default login information, set it up to work with the answer program, things like that. But hopefully we're going to move away from putty and we're just going to use SSH. That's a really quick way to get connected to the system. So if I want to log into the Linux server, and suppose my username is Goblin King, I'm going to say SSH username at linux.engrcs.com, and it'll ask me for my password. Okay, it does not echo anything when you type your password, so you have to have faith in your typing. Hit enter, and if you get something like this, you're logged in successfully. Alright, if instead I were to log into my actual user account, which is nick at linux.engrcs.com, and you'll see me do this fairly often, it does not ask me for a password. Okay, I've set up an authorization key pair so that when I try to log into the Linux server, it can handshake with my laptop and figure out that I'm authorized. Okay, I'm not going to go into the details of that, but if you do some Googling and you look at a file called authorized keys, you can do what's called generating an SSH pair, and you do that with an SSH keygen command, and it gives you a pair of keys, a public one and a private one, and if you put that one of those keys in this authorized keys file, it will let you log in automatically. It's not necessary, right? It's something that we'll talk about if we have time later on, or you can send me email and ask me questions about it. But it's one of these things that, you know, it doesn't ruin my life to have to type my password every time I log in, but this is just a little faster, right? If I've got something I want to do on the server, I don't have to stop and type in my password. And for me, I've actually got it set up so I can just SSH $Linux, and that'll log me in. And I made a lot of typos over the years where I would actually accidentally do an uppercase Linux instead of a lowercase Linux. So now if I do SSH uppercase Linux, that also logs me in. All right. Why am I telling you all this? This is part of the philosophy of Linux. Okay. Part of what we're trying to do is tailor our environment to ourselves. We want to be able to work efficiently in whatever environment we're working in. And for this class, we get to set that environment up as we like. Now, some schools, some places of work may impose things on you. They may say you have to use this version of Linux. You have to indent your code in this way. You have to name your variables in that way. We have a lot of freedom in here, right? As students, this is probably the freest we're going to be in our lives in terms of working on a computer, writing code, setting things up the way we like. And I want you to take advantage of that. I want you to use this year to help figure out, right, what works for you, so that down the road you should be able to set things up in a way that makes you as efficient as possible. Let's see, is that only for a virtual machine? I'm not sure is what only for a virtual machine. But everything I've been saying so far is not just for a virtual machine. This is for running Linux natively, or the login stuff works on OS X also, or using VirtualBox. Let's see, question from someone. On the answer program, are you supposed to force end it? Yes. When it goes back to waiting for teacher, you just go ahead and force end it. So let me do the answer program here. Answer, and it brings up the question that's been waiting for a week, which is, what is your favorite color? And I'll say, orange, because nothing rhymes with it, and submit that. And then it comes back here waiting for a question. So when we do this interactively, and we'll start doing this tomorrow probably, this screen will sit here, I'll type another question, it will pop up. When I'm done asking questions and I close out my program, this will exit for you. It'll say, Q&A session has ended, goodbye. But for now, since I've just got this one question up for a week, when you want to get out of this, just hold down Control and press C. And yeah, otherwise, if you keep running it, you keep answering it multiple times, that's fine. It's really just to make sure everybody knows how to run the answer program. So again, Control C, hold down Control and press C. That terminates a program. All right, so different ways you can log into the system, and if you're using putty, that's okay for now. If you're using SSH username @linuxengrcs.com and you're typing in your password, that's okay. But after the 500th time that you've done that, you may get really tired of typing all of that, and you may say, how do I log in without having to type all of that, right? So come back here to this video, look at this, do some Googling, or send me an email. One thing you never want to do, though, is send passwords in plain text or store passwords in plain text. So I don't want to write a script that types in my password for me and sends those keystrokes over to putty, because then I have my password stored in just a plain text file, and that's a security problem. Someone grabs my laptop, they can look at that, they can see my password. Okay, and that's not how this SSH authentication works up. It's all done using public key encryption systems, so it's relatively secure. All right, so that's how I log into the server. How do I log out? There's a few options here. The classic way is to hold down Control and press D. And this only works if I'm sitting at the beginning of a line. So, I'm sitting here and it's waiting for me to type something. If I hold down Control and press D, that logs me out. The other way to log out is to just type the word exit. And exit will do the same thing as Control D. It ends your bash session. Okay, Control D, in Unix, this is usually a way to indicate end of file. Well, there's no file involved here, right? I'm connecting and I'm sending commands to the Linux system, but it sees these commands that I'm sending as coming from a file. It thinks it's reading from a file. That file just happens to be my keyboard. And so when I hold down Control and I press D, something is saying, hey, whoever's reading this stuff from my keyboard, act like you just read end of file. And when this program that I'm running sees end of file, it logs me out. And I mention that because Control D is something that we'll use a lot in Unix. It's a general way to indicate that we're done putting input into a program. Whether it's the end of our login session or the end of something that we're searching for or things like that. So we'll come back to Control D a lot. But you can also just say exit. That kicks you out right away. And when you log out, you usually get a message saying connection closed. Okay, that's important. If I don't log out of the system and I just go away and I come back in a few hours, my internet connection may have blipped, and I may have lost my connection, and I may be sitting back at, you know, my local prompt on my own machine, but I may still be logged into the server. Okay, that connection may be hanging out there because it didn't get actually logged out cleanly. And if you get too many of those, you may find you can't log in. It'll say something cryptic like, you know, no resources available or something like that. Send me an email, I'll take a look at what's going on, and we can fix it from there. So log out when you're done with your session, either with Control D or with exit. All right. Let's talk about things like putty and SSH and so on and so forth. So CSE224B, you run putty, and you use putty to connect to the CTEX server, right? And in this class, we're going to use SSH mainly to connect to the Linux server. And you typically hear people say things like, I hate putty, right? And what they mean is they hate VI because they don't know how to use VI and it always messes up their files. Or they hate Linux because they can never remember the commands for listing files or compiling a program. But they say, I hate putty, okay? Putty is not the same thing as Linux. Putty is not the same thing as VI. SSH is not the same thing as Linux. So let's disambiguate some of these terms. So here's our basic setup. I've got a laptop. Okay, my laptop is called Nitro because it's an Acer Nitro something or another. And over here, there's a Linux machine called Linux engrcs.com. Guess what? It's not a real machine. I think it's virtualized. Somebody is running something like VirtualBox somewhere on a really big machine, and one of the synthetic machines they've created is called linux.engrcs.com. But to us, it looks like another laptop, basically, right? Okay, so this is a machine that's been booted with an operating system called Linux. Okay, so Linux, that's an operating system. And what is an operating system? Well, that's a whole nother topic. But it's a set of programs that let you interact with the files on a hard drive, basically. That's a horrible definition of an operating system, but so there's linux.engrcs.com. Here's my laptop. This could be running Windows, it could be running Linux, it could be running OS X, this could be a Raspberry Pi running Raspbian, this could be my cell phone running Terminix, right? But on this device, I have some piece of software. Okay, this is a program which might be putty, might be SSH, might be something else. Now my laptop has a keyboard and it has a display. And here's what happens basically when I type something on my keyboard. The program that I'm running, putty SSH, reads that thing that I typed and it transmits it over the magic of the network to this machine, linux.engrcs.com. And that remote machine occasionally types information that I should see, and so it's sent back to the same program, putty or SSH, and that program sends that information to my display. So when I type something like the letter P, what's happening? I'm typing that P, putty or SSH in my case, is picking up that P, it's transmitting it to the Linux server. The Linux server, for whatever reason, is saying, oh, you typed a P, I'm going to display a P. It's echoing that character, sending that back to SSH, SSH sends it to my display, and I see a P appear. SSH did not print that P because I typed a P. It printed that letter because the server sent that letter and said, please display this. And if I do a W, the same thing happens, and if I do a D, the same thing happens. And if I hit an enter, SSH gets that enter key, sends it to the server sees that enter key, and it says, oh, I should show this person what their current directory is, where they are in the file system. And it figures that out, and it says, oh, they're in /home/Nick, and it sends those characters to putty, and putty sends those to my display. So this is not like super critical per se, but I want you to keep this in mind and think about this sometimes, right? We're not really typing directly on this server, right? And we're not running Linux in this program over here. This program, SSH or putty, is a conduit between my keyboard display and something running on this server. And it's just passing information back and forth. And if I say, you know, something like VI, some program name, right? All of this stuff that I'm seeing now, that came from the server. The server saw that I typed in vi.bashrc, enter, and it opened up that file and it sent a bunch of information so that my program SSH would cause my display to look like this. Alright, so this takes us to the next piece of the puzzle. What is a shell? What is bash? In this picture, we have putty sending information to and getting information from this box called linuxengrcs.com. Well, it's not really a blue rectangle. It's actually a blue rectangle with smaller blue rectangles inside it. And one of these rectangles is a program called bash. It's a big C program. You can find the source code for it. It looks like stuff you wrote in CSE224B, just a little more complicated. But it's got if statements, it's got fgets, it's got printf, it's got loops, right? It's got variable declarations. It's just a big C program. But what this C program does is it reads characters coming in from the network, in this case. And if it sees the characters P followed by W followed by D followed by an enter, it will figure out what directory I am sitting in. We'll talk about directories in a minute. And it will print out that directory, /home/Nick. And the operating system will take what this program is printing with its printf statement, and it will send it across the net over to the SSH session that I had. And so now when I say pwd, hello. Now when I say pwd, it looks like, you know, that's my current directory. But it's really just a program in here talking to a program over there. So we have two C programs connected to each other through the network. And that's pretty much what's always happening. Whether you're doing putty or SSH, or you're connected to this machine or to the CTEX server or to some other server, it's just C programs talking to each other. If I go to a web page, so linux.engrcs.com/test, and and this is another page we can talk about, right? I get this web page display with all kinds of strange things on it. But what's happening, there's another C program running on this machine. It's called Apache. And over here on my laptop, I had a program called Chrome. And Chrome and Apache set up a connection and talk to each other. And in my Chrome program, when I typed in that URL and I hit enter, it sent information to the Apache program on the Linux server and said, hey, I'd like to look at the following web page. And the Apache program pulled up that web page, found the HTML code inside there, and sent it back to Chrome. And Chrome displayed it as a web page. Now in CSE222, 223, we'll dig into this in a lot more detail. We'll dive down into this whole sort of client-server model and figure out how this works in detail, and we'll actually write some client-server code and make stuff work over a network. That'll be coming up in spring. But just keep this in the back of your minds, right? When you're doing things in SSH or putty, you're really communicating with a program on this server over here that you're connected to. And whether I use putty or SSH or Terminix on my phone or something else, right, the interactions I have on my Linux machine are the same, right, because I'm talking to the same programs over there. It's just the way I'm getting there, the conduit is different. So let's talk about the shell bash. What does bash do? It reads commands and it generates output. And mostly those commands are about finding files and doing things with files. So for example, if I type date and hit enter, I get to see what the current date is. It shows me today's September 22nd, and the time is 11:35 and 13 seconds. If I type date again, it shows me the current date and time now. It's 10 seconds later. But what's happening when I type the word date? Well, we can use a command called whatis and say what is date, and it tells me date, parentheses 1, print or set the system date and time. So date is actually a program sitting over here on the Linux system, and bash knows when it sees a command from me called date, it should run that program. And when it runs that program, which is also written in C, produces these characters on output. It does a printf that shows me the date and time. And then this program bash takes that output from the date command, sends it back to me. So bash is a go-between that takes commands, executes them, takes the output, sends it back. So my keyboard goes to SSH, which sends something to bash, which will go ahead and run a command like date. And date will generate output, send that back, bash will pick it up, take it, send it to SSH, SSH will send it to my display. We don't need to think about it at that level all the time, right? We just go ahead and we type in a command like date and it runs. But think about it once in a while, and we'll dig down into it over time. Alright, so bash, big C program, reads commands basically from the user, executes them, generates output. pwd shows me what my current directory is. What is pwd? Print name of current working directory. So let's look at this what is business. What is? Well, what is? What is? Display one-line manual page descriptions. Let's see, question, is bash a type of program or a specific program? It's a specific program. It's actually a type of program called a shell. So a shell, S-H-E-L-L, is a program that does this kind of thing: reads input, executes commands, sends output back. And there's lots of different shells. So one of the first shells was called SH. That was the Bourne shell. When I was learning Linux, there was something called CSH. That was the C shell. And it had command structure similar to what C uses, but it's a nice play on words too, right? C shell. And so I learned C shell when I was getting into this stuff. Bash is the Born Again shell. So it's a sequel to the Bourne shell, and it's another play on words like Born Again. And it alliterates nicely Bash instead of BSH. There's the Corn shell, KSH. There's TC shell, which is a terminal-based C shell. There's lots of different shells, and you know, some people get very attached to certain shells, but they all basically do the same thing. But when we get into shell programming, the syntax for doing things is going to vary dramatically from one shell to another. So we're going to stick with Bash in this course. That seems to be popular right now. It'll change over, you know, the next 10 years. But for now, that's a popular shell. It's a good one to use. So I can say what is in Bash, and it will tell me some information, a one-line piece of information about what I've typed. I can also say whereis and type in the name of a command, and it will tell me everywhere on the system that this command might be located. So the date command is associated with files /bin/date user share man1 date.1.gz. These are things we'll come back to shortly. But this /bin/date, that's the actual compiled C program that shows me the current date and time. All right, let's talk briefly about manual pages. So it says display one-line manual page descriptions. If I say man whatis, that goes into the online documentation for this command whatis. So Unix has this built-in set of manual pages. It's a synthetic document. It has 8 chapters to it, and it describes all of the basic built-in Unix commands and all the standard programs that we run in Linux or Unix. So for example, what is display one-line manual page descriptions, synopsis. So there's the name of the command, what is. Here's all what are called switches, things we can use to modify the behavior of this program. And if you know how to read this, this tells you a lot of information about the program. But then you have to go down and look at the details. So description is just, you know, a long spelled out description of what this command does. Description of the options you could put on. So if you want more verbose messages, if you want to do something with wildcards and so on and so forth. And we're looking at this in a system called less. It's like more. Basically, this will display one page at a time. If I want to see the next page, I hit a space bar, and it shows me the next page of this information. If I hit a space bar again, it shows me the next page. If I want to go down a few lines, I can hit the Enter key, or I can do a space bar to go down an entire page. And you can see where I am. I'm at line 90 right now, and I'm still going. Now I'm at line 107 out of 132, and it says end. That's the end of the whole manual page. And if I want to get out of here, I can just hit a Q to quit. Okay, on most systems you can also scroll with your mouse wheel and go up and down like that. And these manual pages always have the same structure, right? There's a description of the command. There's a list of options. If you're interested in how the program has terminated, it will tell you the possible ways it can terminate: success, operational error, and so on. List of files associated with this, related commands that you might want to look at. Author, so who are the people who wrote this. And different commands have different sections, but basically it's you know, the electronic form of a printed 8-chapter manual. Chapter 1 are the general Unix commands. That's where most of our commands will be that we're interested in. Chapter 3 are most of the functions that we'll call from C. Printf, scanf, fgets, things like that. Chapter 8 are the administrative commands. Chapter 6 talks about games, and so on and so forth. ls shows me a list of files in my directory. If you accidentally typo and you switch those around and you type sl instead of ls, you get something interesting. You get this thing displaying across your screen. So if you do a manual page on SL, you'll find out SL is a command to display animations aimed to correct users who accidentally enter SL instead of LS. It's the steam locomotive animation. So that's a nice little built-in command if you need a break from programming. There's a bunch of these scattered around Unix. So what is and where is and the manual page command man will help you a lot. And if you want to know more about the manual command, what do? Check the manual page on it, right? And it tells you all that you need to know about this command. It has lots of options it can take, and so on and so forth. The other thing about the manual command that you should know is keyword searching. So if you're trying to remember how to compile a program, and you don't know that the command is GCC, you can't look up the manual page for it, right? So you can do a keyword search. You can say man-keyword and something like compile, and it will show you all the sections of documentation available related to compiling. Basically anything that has the word compile in the one-line description. So C++, C89, CC, G++, and then down here is GCC. And hopefully you see that and you're like, oh yeah, that was it, GCC, that was the command. And now you can do a manual page on GCC and get help on that particular command. Some of these manual pages are pretty long. GCC has so many options available to it that the manual page for that just goes on and on and on. And nobody reads this start to end, right? But if you're looking for something, you can search inside here for some keyword, and by typing a slash followed by the thing you're searching for. And the manual page on man will tell you about that. Alright, we got a few minutes left. Let's start talking briefly about the file hierarchy. So when you log in, you're sitting in a directory called /home/nic. There's a whole hierarchy of files on the Linux system. So in Windows you would call these folders. But there's a directory basically called slash. That's the root directory. And underneath that there are a series of directories, /usr, /etc, /home, and so on. And I can use the command cd to change my current directory. So if I say cd/, my current directory is the root directory. And I can say print my working directory, it tells me /, that's my root directory. And if I say ls, I can see the files that are in this directory. So there's home, there's etc, there's usr. If I do ls-l, I get more information about these files. And this D sitting in column 1 tells me this file is a directory. And L sitting in column 1 tells me this file is something different. It's what's called a symbolic link. So there's a directory in here called home. And if I cd into /home and I do an ls, I see a bunch of other directories. If I cd into / and then I cd into etc, I see different files in there. Okay, so this is a whole hierarchy of files, and if I do an ls-l, I can see there's a directory here, XML. And I can cd into /etc/xml, and I'm in a new directory. And that has 4 files in it. So cd lets me change my working directory. pwd shows me my current working directory. So I can also move up one level by saying cd ... and ... is an abbreviation for my parent directory, or the directory immediately above me. So if I cd ... now I'm under /etc. If I cd ... again, now I'm under /. And if I just type cd, it takes me to my home directory. And if I want to go into a subdirectory, I could say cd /home/nix/ well, let's find a directory. I could say cd /home/nix/work, right? But since I'm already in /home/nick, I can just say cd work, and that means /home/nix/work. So I can go into a subdirectory just by typing the name of that subdirectory. All right, and so one comment I want to leave you with. We're going to talk about a lot of things in this class. We're going to learn a lot of ways to do things in Unix. And you don't need to memorize these. Okay? If it's something that we refer to a lot, you want to put it at least on your note sheet for exams. And we'll talk about exams beforehand, and you'll know what kinds of things to do. But, you know, being able to do this, or being able to cd ... or things like that, maybe that's useful, maybe it's not. What you want to be trying to do in this course is figure out what works for you. Okay, you're trying to build your own personal toolkit. You're trying to customize your own personal Linux environment to be something that's efficient for you. And we'll go through a lot of things, but some of it will be like really useful shortcuts for you. Some of it will be meaningless. Some of it, you'll do things one way, and after, you know, the 500th time, you'll say, I seem to remember there was a better way to do this. Let me go back and figure out what that is. And you'll figure that out, and you'll start doing it that way instead. Okay? I want you to be very fluid in here. I want you to be open to doing things differently, but don't feel like you have to force yourself. Okay? Unless it's a part of the course, like I'm going to force you to use VI, so that's something I'm going to ask you to work through. But in general, right, and especially for stuff you're doing on your own, find your own groove, okay, and follow that. All right, so we're out of time today. I will leave things there. Tomorrow we'll start digging deeper into Linux and start looking at other ways to work in a Linux environment, and we'll build up from there. All right, thanks. Have a great afternoon. Talk to you tomorrow.